6.7.1, graph the inequality on a plane. Okay, so we got y is greater than 2x. So the big thing to remember about this is when your first steps, you're going to graph the boundary line, which is where it's equal to, y equals 2x. So you can use any of the methods. You can do slope-intercept form. So that's the way I'm going to do it actually. Slope-intercept form. So the y-intercept 0, 0. And then the the slope is the 2. We'll write it as a fraction, 2 over 1. So we go up 2, right 1. So up 2, right 1, and you do it again if you want. And if you want to go the other direction. Okay, now, this is a boundary line. If equal to is part of the solution set, this is strictly greater than, you're going to use a dashed line. But if it was greater than or equal to, then you'd use a solid line. So that's basically, we're saying that the line is not part of the solution set. So all the points on the line, that's where it's equal to, and equal to is not part of the solution set. Okay, now we're going to shade the side. So basically that boundary line splits the graph into two halves. So we got the half where my cursor is, and the other half now where my cursor is. So one of those two sides are true. You have a couple options. You can do a test point. So if I pick a number, say like, let's pick a number right here, 4, 1. If I want to test 4, 1, I plug it into the original statement, y is greater than 2x, and I plug in the 1 for the y, 4 for x, and is 1 greater than 8? And the answer is no. So we can see this side's the false side. So this side would be the true side. And then you would shade. Okay, so that's one method. Another method, if it's in slope-intercept form, greater than, just think, put your pin on the line, and going up would be our true statement. So you can see that this side would be the side that gets shaded. Alright, so we just have to pick the one that looked that way. So 0, 0, up 2 over 1, and we want to shade this side. So that's C.